Okay, let's work number 4 from the 2024 AP Calculus AB exam. We have the graph of differentiable function f shown, -6 to 7, has a horizontal tangent at x equals -2. Let's go ahead and put that. So it's going to be f prime -2 equals 0. And it is linear for 0 less than or equal to x less than or equal to 7. So this part is the graph of a line. Let R be the region in the second quadrant bounded by the graph of f, the vertical line x equals -6, and the x and y axes. Region R has area 12. Function g defined by g of x equals the integral from 0 to x of f of t dt. Find values g of -6, g of 4, and g of 6. So g of -6 is the integral from 0 to -6 of f of t dt. And that's negative, the integral from -6 to 0 of f of t dt. And this quantity right here is just the area of the region R from -6 to 0, area of the curve between the curve and the x-axis. So this is going to be -12. And g of 4 is going to be the integral from 0 to 4 of f of t dt. That's this triangle, the area of this triangle. And since this is linear, that area is 1/2 times the length of the base 4 times the height 2. That's 1/2 of 8, or 4. And g of 6 is the integral from 0 to 6 of f of t dt. And we're going to come up here and finish this up. And that is the integral from 0 to 4 of f of t dt, which we just found to be +4, plus the integral from 4 to 6 of f of t dt, which is the opposite of the area of this triangle. So that's going to be negative because it's below the x-axis. So this is going to be +4, that was this first part, and then minus the area here, which is 1/2 times the base 2 times the height 1, or 4 minus 1, which is just 3. For the function d defined in part A, find all values of x in the interval 0 less than or equal to 6, less than or equal to 6, less than or equal to x, less than or equal to 6, at which the graph g has a critical point. Give a reason for your answer. Okay, so g prime is what we're looking for. Critical points are where g prime of x equals 0. And that's going to be f of x. By the fundamental theorem of calculus, it says if we take the derivative of this, we just replace it with the integrand, evaluate it at the variable on top. And so that's f of x, where the derivative is undefined, or where this one, the derivative is defined even though this is not a linear function going into a linear function because it says it's a differentiable function f. So the derivative is defined, but it doesn't even matter. F of x is 0 at x equals 4. G prime of x equals 0 when x equals 4. Therefore, x equals 4 is a critical point. On 0,6. H, defined by h of x equals the integral from -6 to x of f prime of t dt. Find the values of h of 6, h prime of 6, and h double prime of 6. So here, h of 6 is the integral from -6 to 6 of f prime t dt. F prime t dt. Read back through the problem. This is going to equal, this is fundamental theorem, should have seen that right off the bat, but that's going to be f of 6 minus f of -6, fundamental theorem of calculus. Don't know why I didn't say it to start with. F of 6, this is the graph of f. F of 6 is -1 minus f of -6. F of -6 is 0.5, so it's going to be minus 0.5. So this equals -1.5. And h prime of 6, h prime of x is going to be f prime of x. Same reason we had up here of the fundamental theorem. And so that means that's going to be f prime of 6. F prime of 6 is the slope of this tangent line. We have the point 0.2. We have the point 6, -1, or the point 4.0. Let's just do that. 4.0 it looks like. So the slope between there, f prime of x is equal to the slope of that tangent line, or slope of that line, which is going to be 0 minus 2, -2, over 4 minus 0, 4 equals -1/2. And that's going to be the f prime of 6. And h double prime of 6 is going to be f double prime of 6, and f double prime of x is going to equal 0 because f prime of x is constant. Put it up here. So there's number 4.